Hello, my name is Dr. Professor Satyam Jadhav, and you may know me from Mastering Physics, also as a close colleague of Dr. Stephen Hawking. May he rest in peace. And I'm here to tell you about the 3 principles of design, which are efficiency, cost, and safety. And I know this from my mentorship from Dr. Darren Humes.
Hi, I'm Peter Higgs, inventor of the Higgs boson. While inventing the Higgs boson at CERN laboratory, I learned that copper wires are slow, expensive, and prone to electrical fires. Optical cables, on the other hand, are fast, cheap, and not prone to...
We used 2 Arduino, one acted as the transmitter and one as the receiver. The transmitter was connected to a LED, the receiver was connected to a light sensor. The light sensor and the LED were connected on each end of the fiber optic cable, which would send light across the cable. The transmitter encodes the message and the receiver decodes the message.
10011111001110011110011.
Optical cables work by sending a ray of light through the cable, with a light sensor on the other end to detect that light signal. But wait, wouldn't bending the cable or a slight misalignment of the light source cause the light to not come out on the other end? Actually, optical cables overcome this problem by being made out of a thin strand of fiberglass with a very high index of refraction, surrounded by a cladding with a very low index of refraction. We have a formula to calculate the critical angle, or the angle of incidence past which total internal reflection occurs. Critical angle is equal to the inverse sine of the index of refraction of the cladding material on top of the index of refraction of the glass. We can use this formula to find out that our critical angle is very small, so the light will always bounce off the edges of the fiberglass, eventually making its way towards the end. This emitted light can be read by a light sensor to send a message. Our transmitting Arduino takes an input of a string of characters and converts these characters into integers using their ASCII values. We can write this integer in base 2 as a combination of 1s and 0s. We can flash this signal through the cable using an LED, with a 1 representing the LED being on and a 0 representing the LED being off for any given tick. On the other end of this cable, we have our receiving Arduino. This Arduino creates a voltage difference on both sides of a photoresistor, creating a current. When light is shined on the photoresistor, it decreases its resistance, and therefore increasing the current of that circuit. The Arduino detects this change in current, and uses it to determine whether or not the light signal is currently on. We can use the same system of 1s and 0s, along with the same ASCII values, to convert the light signals back into characters, resulting in an output of the same characters as we initially inputted on the receiving end.
Hi, I'm Al Gore. I invented the internet. Now, let's not beat around the bush, like I did. What are the applications of fiber optics? Well, first we have ISPs, like Google Fiber. Or we had ISPs, like Google Fiber. We also have optical audio cables and transatlantic cables. Wow, isn't this splendid? Do you know in 1854, John Tyndall, a British physicist, discovered that light could be sent through streams of water, discovering total internal reflection. And in 1880, Alexander Graham Bell exploited this property by patenting the optical telephone, which he called the photophone. And then in 1930, Heinrich Lamb went so far as to transmit an image using fiber optic communication. Then in 73, Bell changed the game again. Well, Bell Laboratories, that is, by making a new type of material in which it was cheaper to produce fiber optic cables. Then in 75, the UK police were actually the first to use a non-experimental fiber optic link. And then, in the 80s, telephone companies started using them too. they were rebuilding their communications infrastructure to make it faster. And then 86, another new material, patented by David Payne, and it reduced the cost of long distance immensely. And then, in 91, Payne and Desuvire demonstrated an all-optical system that could carry 100 times more than what was previously capable. And then in 96, something amazing happened. The first transatlantic cable using fiber. And the 97 flag became the longest of those cables, and it used fiber optic communication. Isn't that crazy? Or should I say, insane? Today, all industries, well, virtually all, are using fiber optic communication, whether they know it or not.